also we are getting some kind of not only for the certification but also for the projects. We are making use of these things actually. Like especially in the Databricks orientation, so just we'll be seeing some kind of optimizations. Let us see which are all the aspects. And before that, 1 minute. Um, Let me add one more session. So the Databricks optimizations. Okay. So have a look on this, guys. Just if you're seeing the aspects of optimization recommendations on Databricks. Okay, so fundamentally, as of now, if you refer the Databricks platform, so there are various aspects related to this platform. Okay, so initially, this particular platform provides us. Okay, so it is providing us some sort of notebooks where that particular notebook is helping us to feed the data and to process some kind of the applications. Like if you see the kind of Databricks support, okay. So this thing is basically giving us a cluster support. Cluster is with the usage of the memory. It is providing some memory and as well as the processing. Okay, and the way how we are submitting the jobs is generally, guys, if you are referencing maybe with the help of Scala or PySpark, okay, I can submit my jobs. I can submit my jobs. And if I'm specifically talking about the Databricks service and this particular platform, okay, basically it is providing the ETL. Along with that, we are having some sort of Spark integrated things. And of course, this particular Spark can be architecture can be utilized with the help of Python or else maybe with the help of Scala or SQL or through R. Okay. So though Databricks is not supporting Java, but in other technologies, in other ventures, you can implement with Java also, but it is little costlier. Costlier in the sense in terms of lines of code. Now in the job submissions, so far we have seen some kind of the constructs, no? Like the Databricks orientation, along with this PySpark. Okay, so which is providing some kind of the constructs to notify RDD data frames. So a resilient distributed data set, which is providing a way of accessing the data. Like the resiliency in the sense, suppose I'm having some kind of the data item. If that particular data is unavailable, okay, due to some reasons it is unavailable, then with the properties of this RGD, okay, again we can get back this particular data to the corresponding job. Okay, that resiliency is there, and which is in the format of data set, we can get back that. And data frame is a most commonly used kind of the construct with the help of row column format, and of course, which is a table kind of the structure frames actually. And this particular structure fundamentally helps us to select the data, okay, and filter the data, and to perform some kind of rename and some sort of data manipulations. Okay, all those things, these are pretty normal aspects. Okay, so and that time in the earlier sessions also we have seen either I can use the data frame directly with the notion of this uh, df dot select. Okay, obviously I can supply whatever the data I want, ID, first name. Okay, likewise I can do, and on top of that we can make use of which column renamed. Okay, and thereafter even I can make use of alias like that we have seen. Apart from that, parallelly, one more option is there, friends. This data frame can be converted into the SQL orientation. Generally, if I'm talking about the SQL, I should create a table kind of the structure, table or view. What you can do is just on top of this data frame, I can select create or replace temp view. Okay, off. Just you can take this df underscore SQL like that. Now onwards, this df underscore SQL helps us to venture okay all these SQL based kind of the constructs. Okay, now in what way you are coding in your SQL, similar way you can do that. Okay, so basically either data frame orientation you can take or else Spark SQL. Okay, Spark SQL also you can take. Okay, likewise, we have done some kind of transformations and we have seen some actions. All these things are pretty common in both the things, maybe data frame and Spark SQL. But when it comes to the optimizations, okay, reason is friends, and some of the aspects I have given to you, like optimizations in terms of user-defined functions. Some of the optimizations are there, okay, and we are having some broadcasting, some kind of broadcast variables, and as well as persistence and cache. Okay, these are all few commonly used optimization techniques in case of the Databricks, or not only in Databricks, everywhere if I'm using Spark along with the Python or Scala or whichever, this is most general practice. But here our identification is nowadays Databricks released some more aspects as a part of the other conventions. Okay, so just we'll try to understand those kind of optimizations. Okay, so optimization recommendations on Databricks. Okay, most recent article this one. So this is basically giving provides many optimizations supporting a variety of workloads on the lakehouse, ranging from large-scale ETL processing to ad hoc interactive queries. Okay, so he's trying to give some kind of thing, maybe from the large scale to up to the medium range. Suppose while learning or while researching, maybe I can make use of some kind of POC, or I want to make use of some kind of initial activities. Okay, so in that case also we can make use of these optimizations. So many of these optimization take automatically. That is the reason we are even not aware of that. Okay, suppose to give you one example, while working with your data frame, the same kind of the timing incurred by your Spark SQL also. Okay, that means without losing the advantage of the time factor, in both the cases, maybe the Spark SQL and as well as in terms of your data frame, typical data frame usage, in both the ways you can get the benefits. Okay, so simply by using the Databricks. And additionally, this is the point we require actually. Additionally, most Databricks runtime features require Delta Lake, the default storage layer used to create tables in Databricks. Now, if you observe, friends, in the community edition, okay, we are using only our cluster actually. So that cluster is having some kind of the capacity where you can directly make use of your applications. But sometimes, guys, let me show you this thing. We are having some here a typical AWS cluster where this AWS cluster is having certain aspects like 1 minute. Just tell me that on this one. I'll share some other option with you where you can see here. Yeah. So if I'm making use of this cluster, is a live cluster, friends. AWS client kind of the cluster where this cluster is providing us some heavy storage and processing. Okay, because in the community edition, just we are seeing only the limited access. Okay, that 15 GB kind of the data, and as well as how we are getting in our this thing is there na Google Collaboratory. But whereas in the cluster, where if I am opting for the proprietary kind of the cluster of the Databricks, the option is different. So now you observe here. Suppose if I am making use of the file system, and there you can see the level of the cluster. We are having 7 node cluster, and just you can see all the machines how they are activating, and the data node information. Okay, just how they are launching, how the information is stored. Because in a typical cluster, sometimes I may be working on top of the Hadoop cluster. Okay, just to notify you uh, whatever the functionalities I'm having. So those kind of the functionalities of the Spark can be executed on the entire cluster also. Okay, so this way, if you refer the activities, so just this particular cluster is giving us some kind of whatever the data items, whatever the aspects. Just if I want to verify the configurations, okay, which is giving some details about each machine. Okay, so zookeeper service, all these kind of the services, and data node information, how many. How I can able to access this data. Okay, so status of each node. So these things are actual things, capacity, how we are making use. So some 2.7 terabytes of the data, non-usage and HDFS use. So what I'm trying to portray here is guys, in a typical clustering capacity, see how much data we are adding. So all these kind of things we are using the heavy amounts of the data. So in that particular case, in a scenario like this, so let me put this scenario in this way. Suppose until if you are using a normal kind of the data, suppose I'm having some kind of the data with me, and that data may be in, okay, so just as a typical data, I'm using the gigabytes of the data. So just I want to load and process with the help of Spark. And of course, the pipeline is like this, guys. We want to analyze some sales data, and our requirement is because data engineer part is different, and data scientist or machine learning engineer part is different. Here, data engineer part is if it is a typical RDBMS data, I have to use some kind of the tools, Scoop or something like the kind of the tools, and I need to place this data in file system, and I want to load with Spark or whatever. So unless your data is very simple, directly I can give it to Spark. But whereas if your data is heavy, that's what I'm talking. If your data is heavy, first you need to store into the big data platform. Okay, so the best big data platform is Hadoop distributed file system with the help of HDFS. I can store heavy data. I can store huge data. Now the point is your Databricks, okay, should be supporting or on top of this HDFS. You are going to access the data with the help of the PySpark. Okay, so that means if you are working with huge amounts of the data, then in that particular case, definitely optimizations playing a vital role. Optimizations playing a vital role. So in this case, guys, just to, why we need the Hadoop distributed file system is due to the reliability, and as well as one more thing is the replication. Because our Spark is in-memory computing, guys. Okay, in-memory computing. But whereas for the better analysis, okay, definitely we can use the PySpark with the MLlib libraries, with sklearn, okay, because those particular libraries are really helping us to understand the approach of how we are analyzing the data. But whereas our consideration, especially our DE kind of thing, we want to store and load the data and we need to apply some pre-processing. We need to apply some pre-processing. And one more thing related to this pre-processing, maybe I need to handle the missing value imputation. And the next important thing is uh, engineering. Feature engineering in the sense, friends, maybe you need to generate new features where the existing features may not serve the purpose. And then some kind of encoding techniques we're having. Okay. Likewise, the data engineer perspective is to store, load, and activate the appropriate pre-processing techniques. Okay. Whenever you are working with the heavy data. So, in a way, while referencing these kind of the options, what we are trying to do is we are trying to understand the process of okay how our Databricks is providing some kind of optimization techniques. With that, we are making some conventions, like how how I can access the data and how do we manage those particular things in a better way. That is the idea. Okay, so that I want to talk something about those optimizations, and accordingly we'll plan. Okay, and Databricks runtime performance enhancements. Okay, this runtime performance enhancement in the sense while running the query. So maybe we don't know how much load is exploited to the cluster, and we thought of maybe some kind of the data I have taken, and that particular data is having some insights. Okay, maybe analytical wise, maybe that is a zip file or something. But while running that particular data, the appropriate script is like this. At the time of running the data, so that particular data must be elaborated. So that is what how you can refer this. Now the most important thing is, guys. So let me take this to our OneNote so that we can elaborate it, describe. Let me get this thing, disk caching, which is very important, and we are nowadays we are getting some questions also, guys. Okay, that's what I'm scoping this thing. Uh, the disk caching. Okay, what do you mean by this disk caching and all these things? Let me explain. Because we're having some kind of the observations while submitting heavy data. Okay, so this particular options. These are all options where you can use while submitting your jobs. Okay. The disk caching is something like which accelerates repeated reads against parquet data files, loading data to disk volumes attached to computer cluster. Okay, to compute clusters. This thing, friends, actually caching is a mechanism, is a typical thing. Uh, just to observe this cache memory and as well as the RAM, and maybe we are having some disk. Okay. While any job is running, while any job is running, and already accessed information is available with the cache memory frames. And RAM is little farther compared with the cache memory. And of course, this disk, whenever there is a situation, whenever your RAM or the corresponding in memory is not supporting, then you can make use of this disk actually. Okay, at times, suppose while especially talking the spark based kind of the things, if in memory computing is not enough, the storage is not enough while running the job, definitely it has to go back and take the help of the disk. Okay. Now, if this is the case, then you see disk caching accelerates repeated reads. As I said, the cache memory is something like if I'm repeatedly accessing the data or most frequently accessed data. Generally, guys, assume that we are implementing some kind of like this. There is a flow, like some university approach does. Okay, what they are doing is assume that some thousand scholars are there, thousand PhD scholars are there. What they are doing is, and to submit their thesis, they need to go to the VC and as well as registrar, and then this thing actually, Dean Research, Dean R&D, like that they have to go and catch hold of them because they may be busy and they are not available. So what you can do is you can just you can raise a request with the data entry operator on the department, maybe whichever the department, and it will circulate to all these members. It will circulate to all these members. And this DEO, okay, with the approval of head, so just he can post the things to all the corresponding higher ups. Now, what it does is just a repeated activity, so that VC can easily approve online and as well as registrar can approve. Okay, lot of travel and lot of laborious work can be minimized. Similarly, here also, if you see the disk caching, whatever the activities, because these are all common activities, so that without traversing, just all the things are available, the same kind of thing, hardly the scholar name and all those things will be differ. Okay. So similarly here, in case of the disk caching, the repeated reads and especially Parquet is a default file format, friends. Okay, in our Databricks, if I am observing, Parquet is the default file format, so that they are referring this thing. And whereas in case of other things like Jupyter Notebook and other AWS kind of thing, it may be JSON or CSV, and it is we can also put some default kind of thing. But Databricks maintaining Parquet as a default kind of the format. Okay, this is how you can refer. And the dynamic file pruning. Actually, file pruning, friends, just to observe here. Uh, so suppose I'm working with some kind of activity like this. There is a process of searching. Example I'm taking. Just I'm having some different heads from CTO. We're having some different departments. Databricks is there, as well as Uber is there, and then we're having data services like that. We're having. Now, what I want to do is I want to verify how many I want to get how many PySpark resources are there. Okay, so Uber not using PySpark, so it is ruled out. And data services also nowadays they are handling the things with SQL and Python. And these guys are also definitely not using, of course, Python they are using in terms of DE or DA, but PySpark they are not using. So this is also ruled out. So that means pruning is a way of eliminating or cutting down the unnecessary parts. Okay, at runtime, if you go back to the second thing, so dynamic file pruning, what it does is pruning is nothing but uh, without traversing the unnecessary paths. So dynamically, that means at runtime, these particular prunings, these techniques can be observed, where you can dynamically cut down the appropriate files, improves query performance by skipping directories that do not contain data files that match the query predicates. As I said earlier, here our required query predicate is I want to get the resource of PySpark. Okay, as Uber and data services, they are now the current resources are only with SQL, Python, and Python DEDA, and some other skill set they're having. But PySpark now we are venturing with the database, so I need not go and verify in these two paths. So that is how you can refer the dynamic file pruning. Okay, with the help of that thing. And low shuffle merge. Actually, friend, there is one concept. If you remember, a long back we have discussed this Z-ordered cluster. Okay, Z-ordered cluster is nothing but which is avoiding, which is unnecessary shuffles and all. Because sometimes, guys, while performing the transformations, some of the actions, okay, while running those kind of the actions, they are going to activate all the earlier activities or transformations. So if no shuffle is there, okay, one to one, just one input and as well as the corresponding output. Whereas in case of the complex things like sorting and as well as reduce by key and all those kind of things, definitely I need to internally shuffle that particular data item where there is no one-to-one kind of the matching. There are many to many kind of the communications. So the low shuffle merge, as the name implies, if one thing, friends, if you are able to minimize the shuffling, then automatically you can achieve the optimization because shuffle is the more expensive operation. If I'm talking about in terms of Databricks orientation, shuffle is a more expensive operation. So if it is possible to low shuffle reduce the number of data files rewritten by the merge operations and reduces the need to recalculate Z order clusters. And actually, these particular clusters which are no need to touch base because we are minimizing the merging process and as well as we are in a way we are reducing that particular shuffle. So all the things are easily understandable from this caching rather than directly going and getting the appropriate things. I can directly go and access with the cache mechanism because cache memory, RAM, and disk, this is a hierarchy. And second thing is the dynamic file pruning according to the requirement of the corresponding file. So just we are making use of the resource. Okay, so without verifying all the directories, and this is the most expensive operation compared with the earlier two. The shuffle always, if I'm making use of the actions, shuffle is a common thing. So as to minimize those particular things, which greatly reduces the kind of the access mechanisms and as well as the process. Now, most importantly, friends, adaptive query execution, at least two to three questions we are getting. So this 3.0, maybe earlier 1.x and 2.x, we are having these supports. But in Spark 3.0, they have introduced this adaptive query execution. Okay, where this adaptive query execution provides enhanced performance for many operations, not only the transformations, actions, or all these user-defined functions, broadcasting, persistence, and cache. All these kind of the things can be observed. So now what we'll do is adaptive query execution. Okay, so this particular thing, let me go back to the original source of the data so that you can have a look on that. So just if you are referencing the AQV, the adaptive query execution. Okay, so and this one itself is providing us some kind of additional benefit trends like dynamically start merging and dynamically coalesce. Actually, coalesce is a kind of the process. Okay, whereas if I am talking about the partition mechanism, friends. So generally, partitions I will cover, however, but as the time, as we are getting into this particular thing, so let me give you that thing also. The partition mechanism. Generally, friends, the partition is nothing but suppose I am having some data with me, and this particular data is going to have some kind of the portion of the data. Okay, these are all nothing but partitions. So what I mean to say is that if you are using this D1 to perform job one, okay, automatically this particular job one is dependent on the partition. These are all partitions and which are mapped with the tasks. Okay, there we have seen in the beginning of the session jobs, pages, and as well as the tasks. Like that, we are having some hierarchy. So here, if I am referencing the partition orientation, I can either increase the partition. Okay, I can either increase the partition. Sometimes, maybe by default, if I'm having 12 partitions, I want to increase the partition to 24. I can do that with the repartition mechanism. With the repartition mechanism. But whereas if I'm increasing a partition, then automatically parallelism increases. But whereas there are certain cases, friends, whereas I want to run some simple applications, in that case, I want to reduce the number of partitions. I want to reduce the number of partitions. In that case, guys, I'm having the property of coalesce. Okay, coalesce is a kind of the functionality where I can reduce the number of partitions, and moreover, okay, moreover, this is not going to utilize the shuffle aspect. Okay, as I said, if you can avoid the usage of the shuffle, then obviously you are out of danger. Out of danger in the sense, just you can minimize the activities without much usage of the memory and as well as the space requirements. So with that, just we can have a look on other considerations, so where we can adopt that AQE kind of thing. But AQE already we have seen, but before that, the other optimizations let me cover because adaptive querying already we have seen. So what you can do is just we need to observe the remaining aspects, which are all the other recommendations for the enhanced performance. But my strong recommendations, guys, just you can go through this AQE also, though we have covered. If you observe the AQE orientation, many things were added recently, actually. Okay, that however we'll see in the next session. But now, as we are talking about these in these lines, okay, where the user can observe the enhancements and he can make use of those things. Uh, the adaptive query execution is bit advanced, okay, which is not available for 1.x and 2.x. This is completely from 3.0. Now, some other additional recommendations we are observing. You can clone tables on Databricks to make deep or shallow copies of the source data. Now, see, friends, here the observation. Suppose I'm already having some data frame and simply I want to make use of the data frame architecture or structure of the data frame to my new data frame. Okay, again, going back and running through all these appropriate list or else tuple because there are many methods are there so as to create a new data frame. But whereas from the existing data frame, we are able to perform the process of the cloning. Okay, then definitely it is going to reduce the time factor and extra occurrence. And even in our case also, friends, up to the community edition, it is okay every time to print the data frame and to observe the appropriate architecture and all, appropriate structure of the data frame. But if you are using a proprietary or all these kind of the AWS or some those kind of the cluster which are chargeable, it is strongly discouraged. Will strongly discourage to every time re-execute the same kind of the data frame just for the sake of understanding the structure of the data. This is the common practice, friends, not only in data engineering. In case of machine learning also, because the point is while applying some kind of the algorithm, and I always prefer again go back and see which are all the features I have. So what they're saying is, as a typical data scientist or data engineer guy, just it is always better to make use of the shallow copies or deep copies, just to make use of this cloning. Okay, and cost-based optimizer. Okay, so this cost-based is nothing but suppose friends, I'm having some amount of the data. Maybe it is not require any Hadoop file system or something. Okay, and so maybe directly I can make use of the JSON or Parquet file, where I need not incur on the Hadoop or any other kind of the file system. Okay, which accelerate query performance by leveraging table statistics. Okay, so now one more important thing, the cost-based optimizer is rather than using the data frame, I can simply use the Spark SQL, where the select statement, all these kind of things, and then auto optimization. So these are all nothing but the delta tables, friends. Actually, if you observe the lake house, there which is a fundamental aspect, because even while learning this thing also, they strongly insist us to go with the data lake kind of thing. You see, obviously, if you are observing. So all these kind of the things are byproducts of the auto delta lake actually. So you can auto optimize the delta tables using optimized writes and automatic file compaction. What do you mean by file compaction, friends? File compaction. Okay, compaction is nothing but let me add some more points. So 1 minute. Just let me pick up into our OneNote, which is very flexible to study. Even I can give some views on that. Okay, just to have a look on this guy. So this compaction, what it does is just if you are making use of, okay, so suppose I'm having some data, I want to access some data. Compaction is nothing but your file is there, your data is there, my data somewhere here, and some portion here, some portion here, some other portion in some other location. What compaction does is it is going to fix all these random data values into a common list. Okay. From now onwards, what happens is to for this particular job, rather than going here, 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 and different locations, if I could able to compact them, is a kind of packing them. So this job, okay, is easy. For this particular job, it is easy to pick up the corresponding portions of the data. Okay, that they are saying about the compaction. Okay. Now you can use parse SQL to interact with semi-structured JSON data without parsing strings. This is a beautiful asset, guys, because in case of a normal thing like data frame orientation, if I want to make use of the JSON, you pretty know that your XML, email, and JSON, all these things belongs to the semi-structured format. Okay, all belongs to the semi-structured format. So now is a special consideration, guys. Suppose if you feel I need to use JSON, better you go with the Spark SQL. Okay, so these are all in our hands only, guys. We need not have any additional support or configuration of the cluster or some of the aspects you need to manage. Definitely not required. Only the thing is just with the simple tricks, whatever we are having, just rather than using data frame directly on top of the JSON, if I could able to make use of Spark SQL, then definitely it is optimized, which we can get optimization as a byproduct related to these things. Most importantly, guys, this higher order function. Actually, this is the terminology used in the Scala. What do you mean by higher order functions is, suppose if I'm using function one, within that I'm using some functions. So this function one again calls function two. This function three calls function two calls function three. Assume that is the option. Whereas in Scala, you need not specify all these things individually, but directly F2 like this you can call. So this is like something like 2 into 3 into 4. How you can do that? Okay, like a typical mathematics, how we are using the numbers. In the same way, I can make use of the functions also, friends. That is a higher order function. Higher order function means maybe higher order logic, x square, x cube, x power 4 in the mathematical equations where I in. Similarly, the function, again nested function, again one more. Like that, if I can manage, this is a higher order function. So rather than calling a single function, if I could able to perform this. But in PySpark, we don't have that probability, friends. Actually, we need to venture that Scala orientation. If at all, if I want to use a higher order. So see here, provided built-in optimized performance for many operations that do not have common Spark operators. Higher order functions provide a performance benefit over user-defined functions. Okay, this is pretty understandable because while working with the user-defined functions, okay, guys, the very first point is you have to customize your code. You have to customize, and obviously, while customizing, always we follow up the logic because then basically it is a user-defined function. First, always my approach is I need to implement the result. And of course, if it is a predefined, okay, then I'm having some kind of the statistics. I can know that list is not good compared with arrays if I want to store numbers because I know the complete narration of the array because array holds the same type of the data, and in a way this particular data which is typically holds the numbers, so it need not remember all the heterogeneous kind of the data type, so definitely arrays is better. As predefined functionality, I know that. But whereas in case of the user defined, as a programmer, my context is only to get the result. So after getting the result only, then only I can re-verify my logic and I can apply my optimization. So that is the reason why I always prefer the way of using the predefined orientation. And even Lambda is also discourageable, guys. Lambda, though it is very much helpful to the users, programmers, but Lambda incurs more requirements on the clusters actually. Okay. And of course, the most another important point, friends. Let me conclude with this: the complex data types. So the complex data types are nothing but maybe I want to define my own structure. Okay, within the struct, just we're having the struct field. If you remember, friends, within this struct field, we are having the int type, float type, string type. Okay, like that, I'm having different categories of the types. And apart from that, we are having the array type also. Okay. So at times, while working with this Spark orientation, so just there are certain aspects where I can make use of this structure, array, all these kind of the functionalities. So platform. So just to observe here, Databricks provide a number of built-in operators and special syntax for working with complex data types, including arrays, structs, and JSON strings. Okay, so just have a look on this, guys. Total some 7 to 8 optimizations we have seen. The very first thing is the disk where the cache memory can be used rather than the accessing of the disk, and dynamic file pruning. Unnecessary paths can be avoided. Low shuffle merge while working with the Jada clusters. Earlier, we have talked about this thing, guys, just to recollect. And this thing I'll be talking in the next session, adaptive query execution, which is very much required for our projects and all. And thereafter, just where we have seen the cloning of the data frames from the existing cost-based optimizer. Whenever there is a requirement, then only we can opt for that. And auto optimization for long-running structured streaming jobs for the streaming and compaction, rather than connecting all the different various kinds of the paths. I can maintain a compaction. And semi-structured JSON, preferably you can use the Spark SQL and higher order functions, especially the Scala benefit of that, and complex data types, maybe arrays or struct or JSON kind of things. Okay. So with this, I'm stopping. So just will be meeting you by next week, friends, and we'll post some of the tasks. Okay, maybe by the next week. So just have a look on the some of the tasks, and we'll discuss that. Okay, that's it from my side, guys.
Sir,
Yeah,
so like
this one.
if we, yes, sir, we
Hmm.
choose struct type
Ah.
that field.
Hmm.
So is which is preferable? Should we like define the data types in array or in struct type?
Array, if you are taking that particular array, generally Ridwan giving us the complex type. Maybe if I want to see that as a single unit, I can use the array. But the most flexible way, suppose if I am making use of, suppose this is the thing, name is there, and skill set is there, and experience like that I'm having. In that case, most preferable way is struct. Most preferable way is struct. Whereas if you are working with sales and your sales data is only there, only on that particular column you want to apply some mechanism, then your array is best. As I said, na, array is a common, which is holding the common type of the data, and that is your wish. Maybe your number you are sharing or floating or string, but you have to store the single value or single data item. Okay, single data type. But whereas if I'm talking about the struct type, it is your wish. Maybe you can use the int type, string type, or float type, all these kind of the thing. Provided if your data is having heterogeneous kind of the data item, then you can go with the struct type. Whereas if your data is only holding a numbers or only single kind of the data, then you prefer the arrays. Okay, no?
Yes. Yeah.
Yeah. I'll take one example, Rizwan, in that case, no problem. Next week, I'll showcase this struct usage and as well as the array so that you can easily get the point, right? Okay.
Okay, okay, sir.
I'll do that. I'll do that. Okay. Thank you. If any doubts you are having, just post me so that I can scope in the next week. Hope you are preparing well, na?
Yes, yes.
Okay. Okay. Do well all the way. Okay. Thank you.
Thank you, sir.
Thank you,
Bye.
Deepika. Bye. Mm. Bye.